and welcome to Wednesdays with iGTB. This week, we're talking about bank on a tile. I'm joined today by two experts, both in the new architecture for provisioning and deploying rapidly. First of all, I want to welcome Robin Huiser. Robin is the architect for the digital team in Intellect Global Transaction Banking, iGTB. He's got over 20 years experience working on digital transformations with banks, including putting in new corporate banking channels. Welcome, Robin.
Thank you. Glad to be here, Phil.
I'm also honoured to be joined by Vincent Caldera. Vincent is the chief architect in RedHat for financial services. He too has over a decade of experience working with banking and financial services companies, again, putting in the new technology, cloud native, microservices, all built from the ground up. Welcome, Vincent.
Yes, thank you, Phil. So I'm quite thrilled to be here.
We call this bank on a tile because we've all heard of bank in a box, but the new technology is about Kubernetes Operators, tiles and the like. And people understand the promise. It should be very quick. It should be very simple. But there are difficulties, and we're going to cover that. It's an interesting thing that financial services, it may be ahead of healthcare and utilities, but the real competition will be coming from the tech giants, from the Amazons, from the Alibabas, and they're very comfortable in this field. So financial services really needs to pull its socks up, and we're going to explain how. Vincent, please tell us.
In the sense that I think we are really touching a subject that is at the core of the modernization issue that we typically discuss with customers at RedHat. And by this, I mean that if you think about it in terms of adoption of new technology, it is quite frequent to see that there has been a rapid adoption of new technology by banks, in particular in the context of digital banking, and all the services that we as banking customer, we can also see being deployed via mobile applications and other digital means to us. But at the same time, if you start to scratch a bit beyond the surface and you look at the back end inside the typical financial institution, you will see a large number of legacy systems that have not really evolved in the past 10 to 15 years beyond really minor upgrade. And if you happen to discuss with the application team that are taking care of this system, you will actually hear a lot of pain in terms of how complex the application management really is. And also what's always interesting to see is the fact that those institutions need to rely on a large number of very expert teams that have deep knowledge about a specific application, and they seem to be the only people who really understand the complexity of deployment of daily operation needs, and there's a huge dependency on these people to actually keep the lights on, which if you think from a financial service industry perspective, it can actually be a bit frightening.
True. So what have we seen, right? Once we get within banks. So container technology seems to be the next answer, right? So you basically want to cut the knowledge about how to deploy a specific application and keep that within the minds of a certain key staff, right? You want to push that into automation. So container seems to be the first step. So that's what we're going to talk about today, containers, and how we can deliver our software as containers into the financial industry. But it might not be as straightforward as you today think. I will start with the very beginning. So how do you bring a container to a bank? Well, most of our banks have a zero trust model, which basically means that they don't trust anything that you deliver them. So traditionally, when you would deliver software to a bank, you would deliver a jar, an EAR file, and they would deploy this on a very well-controlled, secured, and managed environment. But with containers, you're actually shipping the middleware embedded right within the container. A whole set of banks worldwide, they said, you cannot deliver us Docker images. We need to build these Dockers ourselves So this has a huge impact on your software delivery method. The next stage is once you have delivered the software, and we'll show a little bit further in this webinar how we do that. You basically want to start your container. So the bank has built its container against its approved, secured, and certified internal parent Docker images. And we have now something that we actually can start, right, on a container system. Every application that we deliver needs configuration, right? We have over 60 microservices within the CBX stack, and every microservice requires its own business logic configuration, which we segregated from environment configuration. Which means with 60 microservices, we have around 120 configuration files, which is a whole lot to manage. And this can be quite intimidating for a bank that starts with container technology. So this might be challenging for a bank, right? Because the bank not only has to deploy 60 microservices, it gets also 60 sets of configurations in 120 different configuration files. So how do we handle these new and deprecated keys, right? And how do we handle these default values? This is something that we have developed a certain pattern for. We're using some utilities that allow this migration and merging of new and old key value pairs automatically.
So I'd just like to jump on this, Robin, because it's very interesting for me to hear. You know, it's quite clear here that it's not possible anymore for a human to take care of all these dependency, and some of these are actually quite critical. Take the example, for example, of a microservice deployment, and you mentioned the security topic a little bit earlier, and I think it's a very critical one in the FSI world. In a microservice world, you need to configure a trust between services on a service-to-service basis, which means that you need to deploy certificate and manage the certificate deployment versus the certificate authority that the bank has elected to use.
You're completely right. So that's one of the challenges that we face day by day when rolling out our software. It's not possible, right, to manage all of these settings manually. So specifically, if you consider where you can get configuration from, right, we inject configuration through environment, we inject configuration through Spring Cloud Config, and we also need to have a solution specifically in this industry to assure that secrets, which could be passwords, it could be certificates, it could be trust stores, right? Anything that you typically don't want to be deployed on a file system where everyone can just access. We have integrated with HashiCorp Vault, for example. The beauty of this, and I think it's not something that a lot of people realize, but today in a traditional application deployment, if an application requires access to a database, for example, the operator of the Kubernetes cluster or OpenShift, right, requires to have access to the credentials of that database because he or she needs to configure that. With our solution, you no longer need to. There's a complete segregation between the operator deploying the software, the security team within the bank, and the software delivered by iGTB. There's no need, no way that the operator, the human operator in this case, needs to have any access to any of the databases, the credentials, or whatsoever. But there's so many other things that you need to take into considering when deploying against the platform. I'll just give you a couple of examples. A microservice will reach out to remote endpoints, right? That's the whole concept here. Now, how do you verify that each of these microservices are actually capable of reaching out using the provided credentials? So that is something that you will need to test and verify as part of your deployment. Think about queue and topic definitions, right? In RabbitMQ and Kafka, where under development circumstances, you are allowed to dynamically create these topics and these queues and these exchanges, but a bank doesn't want that. A bank wants to predefine them because they need to monitor them. They want to make sure that they're tuned properly, etc. They want to know what is being created, right? Specifically from an operational point of view. Think about data priming, right? So when you have Elasticsearch, you need to define the indexes. You need to tune the indexes. You might want to migrate data structures from A to B if you have a software update. You want to bootstrap maybe some data in there or inject test data for performance testing, right? All of these tasks are done today manually by the operations team within a bank, and it's quite a lot of work. Now, even if you have your microservice deployed with the right configuration, you are sure that it can connect to any of the other backends, such as databases, Elasticsearch, and Redis and Rabbit, you're still in a platform concept. And we as iGTB, we deliver a platform. You need to register your vertical package, right? We call it a domain pack, such as cash management, CNR, liquidity, payments, account services, all those modules which we can just plug onto this platform. They need to register themselves with the platform, right? They need to tell the internal service router, hey, route some traffic to me. They need to tell the workflow engine, hey, keep me in mind when you're running an approval workflow. These are my requirements. We have data mapping engines which basically translate formats from A to B, so the microservice can be of any dialect plugged into the system. We have scheduler services, etc., etc. So if you look back, right, there's this whole long list of tasks, of items that you have to verify. It's not enough, right, to just deploy a container today.
Yeah, I really love these examples, Robin, because if you think about it, right, you have a high number of different service dependency, but in fact, even I think just mentioning that those would be done manually in a typical financial service industry environment is not enough to understand the complexity, because a lot of the checks that you mentioned, they couldn't even be performed by a single individual, like checking the availability of a messaging topic or checking the data model in a database. All these are typically privileged activity that are performed by different teams and different individuals who all need to get a specific authorization to have extended privilege during a period of time to perform those checks. And this is what, often it's not trivial for people to kind of understand this, but an entire deployment of a critical application, there is no surprise that typically an IT team will schedule to do this over an entire weekend. And it actually takes a lot of people to get involved, often working at nighttime to verify that certain services are ready to proceed with the next step. And I think if you haven't been in this situation of deploying in this type of environment and understand how critical it could be to miss one single step in the entire deployment, and it could literally mean that you have to decide on Sunday night that you cannot go live with the system upgrade, then you start to understand the kind of risk and difficulty behind those processes. So I think these were really great examples because you covered like some of the really frequent dependency that we actually observe and which often result into deployment mistakes or deployment issues.
So when we started 4 years ago, right, with delivering microservices, and we were way ahead, specifically in the corporate banking industry, the majority of the banks, they had a really hard time, right, to wrap their head around about, okay, what is the benefit here? I have so many deployables, so many configuration out there. What do I get out of it? And I had to spend many, many sessions with many CTOs and CEOs to explain that, well, the payback of a microservices architecture is all about your blue-green deployments on microservice level, container level, your canary releases, your dark releases, and basically you can save cost by, you do add complexity, but you can save cost by not having to spin up and maintain 5-6 environments, because that is what in general a bank does, right? For an application, they have around 5 to 6 environments up and running. And basically by using these techniques, you can minimize the set of environments by at least 3 or sometimes 4, depending on what you choose. This was 2-3 years ago when we really had to have these discussions and what is the benefits of this architecture. What we see today, and that this is what is happening with the RFPs that we get today, is that actually banks are asking for these things. Can you do a canary release? Describe a blue-green deployment. Do you support dark releases? So there is a shift in the financial industry from being presented with a solution that you don't fully grasp, but you want it because your fintech competitor does it, right? And apparently they are able to do a quick turnaround in functionality, towards understanding what it's about, towards actually making it a requirement to participate in RFPs.
I mean, it's really great to hear about I would say, the evolution of mindset. I'm sure the cost element will be extremely interesting to CTO.
So this is where we are, and on top of all the challenges that we have presented right now, right, from container to configuration to tasks to platform registrations to different ways of updating your software, we have the final challenge to overcome in our area, which is basically every one of our clients is managing their own environments. It's not that iGTB today is providing a software as a service option and we're in full control how things are configured, what the processes are. No. We basically do a software handover, right? And from there on, we leave it to the client and their IT team to operationalize our solution. In order to provide a solution, we had to make 3 steps as an organization. The first step, and you can see that on the slide, is basically we define and version our bundles. So instead of delivering 60 individual microservices each with their own versioning, each with their own configuration, we said, okay, let's group these microservices within their bounded context, right? Let's group these microservices within a logical domain. So basically what we have done is define for CBOS 4 different bundles. We have the foundational services, which is basically anything that you need to run, right, for microservices, such as configuration entities, registry entities, internal routers, schedulers, etc. Nothing really banking specific, but you just need the stuff to get into a microservice environment. We have approval services that has everything to do with how do I get an approval in the channel. We have horizontal services, which are basically microservices delivering a service used across any domain. So I want to export data. Well, I need to export data from my payments. I want to export data from collections. I want to export data from liquidity, right? It's a shared capability. So we call that horizontal services. And we have open API services. So instead of delivering 60 individual microservices, we basically deliver now 4 bundles. Each bundle is versioned, and each bundle has a certified, pre-tested set of microservices integrated. That's step number 1. Step number 2 that we had to make, right, is basically embrace the deployment context within components, right? When you deliver a microservice, it is not only important that you deliver the binary, which needs to be containerized, but that this binary also tells how it is configured, how it needs to be deployed, right? And deployment is broken up in 2 steps. The component will describe how it can be containerized, so because banks need to build their own containers. We saw that earlier in the presentation. And the component needs to tell how it can be deployed in any platform as a service container system. Lastly, the platform registration and the tasks need to be applied, and the component needs to be able to tell where to register. In the example that I have here next to me, you will basically see that Gatekeeper, which is our internal service router, will be told to register this component, and we have some tasks ready for this component to be executed. Remember the tasks about creating topics and queues in RabbitMQ and basically the connection testing. This is typically what will be in this task. Last but not least, you will see at the bottom of this slide here, the artifact itself. It's a jar plus a digital signature, which can be validated, right, before actually building a container. So there's an end-to-end trust model. The last thing that we need to do, so we have 3 steps, right? We basically said, let's bundle our software in such a way that we do not overwhelm the bank with 60 individual deployments, but just 4. Step number 2, we basically have the component tell how to deploy itself. It no longer needs to be in the head of an operator. The component will tell. Step number 3, we deploy automation embedded within the delivery. So how do you ship a pipeline? Because this is actually kind of a pipeline, right? If you think about it. How do you ship a pipeline within your software? Okay. Now we have chosen to use the OpenShift Ansible operators with a touch of Golang.
And I think what you described very well is with the adoption of operator, we see this as a complement of Kubernetes that lets you embed and add all this application-specific logic that normally a person would need to know on how to operate between all the various components and the complexity that is involved.
Look, right? Why don't we show the world what we have done and deploy CBX Foundation here? What do you think? Sounds good?
Yeah, would be great.
For the purpose of this demo, we have deployed the latest and greatest version of OpenShift Container Platform, and I will just guide you through the couple of steps that a typical operator within the bank, right, the human version, requires to do to deploy CBX Foundation. First of all, we need to load and tell the OpenShift operator logic that there is such a thing as a CBX operator. So this is what we have done. It's basically pushing some CRDs, right, custom resource definitions, into the OpenShift cluster. It's a couple of commands. We have done that for you. So the only thing that the operator logic of RedHat knows, that there is such a thing as a CBX operator. Nothing is deployed. It's purely definition. So let's deploy the operator first. We've created a project, webinar, it's empty, and let's look for CBX here. There it is. And we basically here have the CBX operator, and we're just going to install it, right? So here we basically kick off the deployment of the operator itself. Now the operator is basically a nanny, and this process that is started assure that a desired state is enforced. Now we're going to tell the operator after it started what that desired state actually is. We'll have to see when the operator is started. You will see that the operator is here. If you go to workloads and pods, you actually see that the operator is running. It's a pod, it's nothing else. It's a container running, and it's waiting to be communicated with the desired state. Okay, that was easy, right? Installed operators. We go into the CBX operator here, and we see that we have a CBX Foundation tab here. This basically will tell the operator, okay, deploy CBX Foundations for us, and we need to specify through a YAML file and the versions that we want to deploy. Let's keep the versions as a default, right? The operator will basically take care of downloading these versions from the certified registry within the bank, right? And start deploying them. Okay, we'll click create here. You will see that a CBX Foundation task was created. We click on this, and we basically can see dynamically which resources will be created. There we go. So the operator has now a desired state, and will try to get my space, right, my project within CBX into that desired state. Now, we have seen on the previous slide that the foundations part of CBX contains configuration services, registry services, routing services, scheduling services, a lot of services. Here we basically see the operator instantiating any of these services, configuration and service definitions, right, and the containers itself. When we look at the pods, you suddenly see that a lot of these pods are started, and well, as with any Java Spring Boot environment, this takes some time to wave out, right? All these services are running, they need to initialize, health checks need to be taken care of. Yeah, that is basically what is happening right now. Any insights from your part so far, Vincent, on this aspect?
So what I like to explain, right, to understand the concept of operator, and I think it particularly ties very well with, I would say, the expectation of how applications are managed in the financial service industry. An operator is no less than a controller application. So as you mentioned, the state you have defined for your application is the state that the operator has to ensure. So behind the concept of operator, there is also a concept of compliance, right? the way you have declared the application state and how it should be run is you are going to ensure that it's actually run this way. And what's interesting here is you know, the operator that is running constantly on the cluster is going to respond to any event that would result in the state of the application being challenged, right? So those can be availability events, those can be, I would say, even performance-related events. So we see application of operator now that go beyond the installation and update, which is already very helpful. That could also include how you want to manage the application state to respond to different conditions of running the application. So one example of this would be under extremely stressful conditions that you may expect, you know, at the end of the day as part of a batch, you may actually want to change the amount of processes that can support a heavy batch load on the application. Technically, I have been in my career exposed to operations team that had to pretty much stop services and restart and you know, and spawn additional services on additional machine to meet certain service level agreement in terms of batch processing. So imagine how cumbersome this is. You can again automate all this kind of day two management logic that is application specific. And I think that's the beauty of it, right? And that is also a concept that I would like to stress is obviously not purely limited to application vendor. From the customer point of view, you can actually extend the logic to include certain, I would say, organization-specific logic, such as some of your policy around log management, or how often you want to regenerate security keys between services based on your own internal policy. So you can start to kind of apply all these principles to cover all the typical manual operation activity that you may have to carry. And this is what is very powerful with the concept of operator.
In the end, we have the state that we desire, the operator took care of this. Now, I realize this is not super exciting. We can provide you an overview registry. We actually see that service registrations have gone fine in this platform, Digital Config, Digital Gatekeeper. We basically deployed with, what, 2-3 minutes work, right? Fully the CBX foundation layer working without errors. That is the power of operators. CBOS is the underlying platform that we provide, which allows you not only to run all the domain packs that iGTB delivers, such as payments, accounts, collections, receivables, but also allows any financial organization to extend and build its own integrations with its backend processors. So you're not bound to our backend processors for that matter.
Before we finish, I've got one question for you, a really important question. When you talk to the CIO, most CIOs I know are numbers people. They're interested in cost. Tell me, what does this do to the cost of the IT team?
Oh, I think I can answer it, right? So delivering the software to an organization is one thing. Getting it operationalized is another thing. And specifically, the operational excellence of the platform is tremendously brought down using operators, where previously you had to train people how to deploy, write endless manuals, practice over and over again for deployments, for basically moving to the next environment. The operator assures that everything is done, ticked and tested before it even enters the premises of the bank. So this will bring projects down by months.
So with that roundup, I'd like to say thank you very much to Robin.
You're welcome. It was amazing to be here. Good experience.
Thank you, Phil, for the opportunity and great chat with Robin today.
That's about it. But before we sign off, I'd just like to mention again that on Wednesday the 12th, we have a very special webinar coming up about contextualizing corporate cash management. So while we've just seen what's going on in the engine room, this will be much more about what's happening for the clients and for the bank. That's with Christine Barry, the very well respected and well-known analyst from IT, and Herbert Reuter, our head of digital and payments. So please don't miss that one. It should be pretty special. Okay, so with that, thanks very much to the audience. Thanks very much to those who asked questions. Thanks again to Robin and Vincent. and we'll see you on another Wednesday with iGTB soon.